this project-based learning, we are creating a news article-based website. This website is titled Newsin. Newsin is a website to read, post, and or create article from whatever you want. So this is how the website looks like. To log in into the website, you can simply press this text login, and it will be redirected to the login page. Here you can fill the email, password, and roles with the specific roles that you have, and the account is based on what you already created before. When you don't have an account, you can click the sign up here text to create an account, and if you lost your password, you can click reset your password here. Because I don't have an account, so I'm gonna an account here. So to create the account, you have to fill all of these fields based on your identity. For example, I'm gonna fill with my own identity here. You need to create the account with the real email account. After you create an account, you will given a page that told you to check your email. The website have sent you a link to your email, and you need to click it to verify your account. So this is how the email looks like when the server is sending you an email. You need to click one of these link or the button. You can click click the button here. After you clicking the button, your account will be verified. You can go back to home page and go back to login into your account. In here, you have to select the reader. This is the default role, because if you want to be a writer, you can request it to the admin to write the news or the article. After you log in, you will go back to the home page, and the login and create account button will be changed to the welcome message. In this button, you can change your profile information. Here you can change your profile picture, change your username, email, and your name. After you log in, you can read the news or the article that already made by another user.
So in our project, we also use Tailscale to securely connect two different network infrastructure through the internet. We install the Tailscale plugin on a both OpenSense firewall instead of configuring a traditional site-to-site VPN. On this page, we can see two devices in our telnet, OpenSense on the left infrastructure and OpenSense SoC on the right infrastructure. Both are connected and have their own private Tailscale IP address. The subnet labels means this firewall is sharing its local network with the telnet. In other words, it works as a subnet router. Here we can see the subnet router advertised by this firewall, including front-end, back-end, backup, and control network. These are the local network behind the left OpenSense firewall. Advertised router tell the telnet which local network can be reached through this firewall. The router are listed as approved, meaning they have been verified by the telnet administrator and are ready to use. This firewall is also configured as an exit node, unlike advertised route, which provide access to specific local network, and exit nodes forward all internet traffic through this firewall. This is the second firewall. It advertised the CM, SOAR, and MISP network. As a result, both infrastructure can securely communicate through the Tailscale. This is the key page. Here we manage out keys, which allow new device to join the telnet automatically. In our project, we use a reusable out key to simplify deployment.
This is the admin view in the Hive, where we can see all organizations registered in the system. There are two. The first one is admin, which is the default organization used to manage the Hive platform itself. The second one is Newsin CSIRT, or Newsin Cybersecurity Incident Response Team, the organization we use for our CM SOAR project. And after entering the Newsin CSIRT organization, we can see two tabs, Users and UI Configuration. For this demonstration, I will focus on the Users tab. Our organization currently has 5 active users, each assigned a different profile based on their responsibilities. And now, I will log in as Aina Hanifatur Banilfat, who has the OIG admin role. As shown in the top right corner, I'm now logged in as Newsin CS IRT or AINA. At the top navigation bar, there are several main menus. Like the first one, New Case, that allow us to manually create a new incident case. And then Alerts currently contains 33 alerts which can later be escalated into investigation cases. And then there is Dashboard, provide visual monitoring of incident and activities. Next, I return to the list of alerts. Each alert contains several important pieces of information, like severity, that indicates the alert priority using color coding, then read and title, case, type and source, reference, observable, and dates. Now, I will open alert number 7 to exit notes feed. The preview displays basic information including the alert ID, date, type, MISP reference, source, and a description indicating that it was imported from MISP number 7. At the bottom of the preview window, several actions are available. Merge into case for attaches the alert to an existing investigation instead of creating a new one. There is an import alert as drop-down menu. By default, it is set to empty case. Clicking yes, import converts this alert into a brand new investigation case. Now, I return to the main page by clicking the Hive logo and open the list of cases. I will open case #5 new malware rover targets Indian ambassador to Afghanistan. The case information remains the same as when it was first created. It has medium severity, TLP white, PAP amber, sent to myself AINA, and text including CRC and TLP. At the top of the page, we can also see that case has been active for approximately 2 hours. Several tabs are available including text, observables, and TTPs. And we are in the text tab. There is one text named Analysis File X, and the text has already been completed. I open the Observable tab. The case contents for Observable imported from the original alert. I move to the TTP tab. Currently, it is empty, showing 0 of 0 tactics, technique, and procedure, meaning that no Mitra attack techniques have been mapped for this case. I return to the list of cases. Our organization currently has 4. The most interesting one is case 9-5, Remtasu obtaining Facebook accounts, which has already been closed. The case contains 1 text, 2 observable, high severity, and a set to myself, or AINA. Most importantly, a summary section appears at the bottom of the page.
This is Open Media Vault dashboard. In our project, Open Media Vault acts as centralized backup server. It stores automatic backup from the database server and Wazoo server. The backup process is scheduled automatically using systemd timers on each server, while Open Media Vault provides centralized storage and interface to monitor the backup service. This page shows the storage device used by Open Media Vault. We can see that the disks are mounted, online, and ready to receive backup files from the database and Wazoo server. Here we created share folder to separate different backup data. The backup folder stores MySQL database backup, while Backup Wazoo stores Wazoo backup. This separation makes data management easier and more organized. This page manages user account. We created dedicated users such as backup user and Wazoo logs so that each server has its own access permission when sending backup file to Open Media Vault. The file browser service provides a web interface to access backup files. After backup are transferred automatically, administrator can easily verify, download, or manage the stored file through the browser. This is the login page for the file browser service. In this page, display the backup file stored in the Open Media Vault. Each file has a timestamp showing when the backup was created. Because the backup are generated automatically by systemd timer on the database and Wazoo server, new file will continue to appear according to the configured schedule without manual intervention. This is MISP, our cyber threat intelligence platform. MISP is used to collect, manage, and share threat intelligence, especially indicator of compromise. Here is the detailed view of an event. At the top, MISP displays the event information, including the event ID, UUID, creator organization, and so on. The threat level helps analysts prioritize incidents, while the distribution setting control who is allowed to access the threat intelligence. The analysis status indicates the investigation progress. On the left panel, MISP provides several actions for managing threat intelligence. Analysts can also add new attribute or object. The administration menu allows administrator to manage user and access permission. Each user can be assigned different roles and privilege depending on their responsibility. MISP also support API authentication through the authentication key. This API enables secure integration with external platform. In our project, we use API authentication to connect MISP to the Hive and our automation workflow, allowing threat intelligence to be exchanged automatically without requiring manual intervention. Return to the event list, we can see that many events contain classification tags describing malware types, OSINT source, threat level, or attack categories.
To secure our infrastructure, we implement two primary security layers in OpenSense, one firewall rules and intrusion prevention system IPS rules. Under the one firewall rules, we enforce a strict security policy. All general access to the internal network and ICMP ping requests are completely blocked. However, we explicitly pass HTTP and HTTPS web traffic on port 80 and 443 strictly to the web server at the IP 10.10.23. Next, in the intrusion detection model, we have enabled the DOS rule set with a drop action. Functioning as an active IPS, the system automatically drop malicious packet in real time whenever DOS or DDoS attacks such as SYN, ICK, or ECMP flood are detected.
Now let's move on to the OpenSense on PC2. In our topology, this firewall protects the CM and SOAR network, including Wazoo, the Hive, Cortex, and MISP. Besides filtering traffics, it also works as a Tailscale subnet router and runs Suricata IPS to inspect and block malicious traffic. This is the Tailscale plugin installed on the OpenSense. Here we connect OpenSense to our Tailscale network using authentication key. We also configure the advertised route, which are the local network that we want to share through Tailscale. In our project, PC2 advertised the CM network, SOAR network, and another internal subnet. These allow device to connect to the Tailnet securely to access this network. The status page shows whether OpenSense is successfully connected to the Tailscale control plane. Next is the one firewall rules. These rules control traffic entering OpenSense from the internet. In our project, we created rules to block unauthorized access to the SOC network while allowing the only required traffic. This is the first layer of protection before traffic reaches the internal service. Now we move on to the Suricata IDS and IPS. Here we enable IPS mode and choose which interface should be monitored. In our project, Suricata monitors the one interface, Tailscale interface, in the internal VLANs. This allows attack to be detected not only from the internet but also from VPN connection and the internal network traffic. This page contains Suricata detection rules. Each rule detects specific attack patterns such as DOS, DDoS, malware, scanning, or exploit. We enable only rules that match to our project requirement to improve performance and reduce false positive. When a rule is triggered, Suricata can generate alert and block traffic. In our project, every web-based service is securing using HTTPS. This includes Newsyn.com, Wazoo.newsyn.com, OpenSense.newsyn.com, and so on. Each service has its own SSL certificate, but all certificates are issued by the same internal public key infrastructure. This is the certificate chain used by all our services. We generate every certificate using OpenSSL. At the top is our root CA called CA PBL RKS 316. Below it is the intermediate CA named server CA PBL RKS 316. And finally, each service has its own server certificate, such as Newsyn.com, WazooNewsyn.com, and so on. Although each service has a different certificate, they all follow the same trust chain. We choose an internal public key infrastructure because this project is still in a development and simulation stage. It allows us to issue HTTPS certificate for every internal service without depending on a public certificate authority.
In this project, we are using NXN to automate our security incident response workflow, as illustrated in the video. The pipeline ingests alerts via a webhook, parses the data, and checks MISP for existing events. If none are found, it gathers threat intelligence from VirusTotal to create new MISP events, simultaneously interacting with the Hive to automatically generate cases and add artifacts before sending real-time notification to the team via Telegram.